Today's lesson is section 10.3, arcs and chords. If you remember, arcs are the outer portions of the circle. So on a circle, from like here to here along the edge would be considered an arc. And then chords are segments that touch on two ends of the circle and go through the circle like that. So a diameter is a chord, but any segment with endpoints on the circle is a chord. So the first thing we're going to look at is in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that says is this arc FG is the same as this arc JH as long as the segment FG is the same as the segment JH. And the reverse is true. If I know that the two arcs are congruent, that would make the two chords congruent. And this works in the same exact circle or congruent circle. So the circles can be separate from each other, and this is still true. So in example 1, we have a circular piece of jade is hung from a chain by two wires wrapped around the stone. Segment JM, which is a chord, is congruent to segment KL, and the measure of arc KL is 90 degrees. We want to find the measure of arc JM. So we just learned that if two chords are the same, their matching arcs are the same. So if arc KL is 90 degrees, that makes arc JM 90 degrees. And that's all there is to it. We don't have to do anything to the problem. In example 2, we have circle A is congruent to circle B. So these circles are exactly the same size. And they're telling me that arc WX is congruent to arc YZ. So since these two arcs are congruent, their corresponding chords would be congruent. So I know 7x minus 2 is equal to 5x plus 6. So I'm going to set them equal and solve. I know I could subtract 5x. I can add 2. So now 2x is equal to 8. Divide both sides by 2. We get x is 4. But we're not done. They want us to find wx. So wx is 7x minus 2. So we're going to plug that 4 back in. 7 times 4 minus 2. 28 minus 2. Which means wx is 26. All right, you're going to try the next one. So pause, and when you're ready, come back and see the answer. All right, if you did this correctly, you should get x is 4 again, and then rs is 11. All right, the next thing we'll look at, again, same circle or congruent circles. Two chords are congruent if and only if they are equidistant from the center. And if you recall, when we talk about equidistance, we are talking about the segment that is perpendicular to it. If there is no right angle, it's not the distance from the point to the line. So they're saying if LX and LY are the same, then FG and JH are the same. And if FG and JH are the same, then LX and LY are the same. So in this problem, they're telling me that EF and GH both equal 24, which means they're the same as each other. So we want to find PQ. So because these are the same, these are the same. So I can set 4x minus 3 equal to 2x plus 3. Subtract 2x. Add 3. And now if I divide both sides by 2, I get x is 3. And I'm really looking for PQ, so I'm going to plug it back into 4x minus 3. So that's 4 times 3 minus 3. It's 12 minus 3. PQ is 9. All right, you go ahead and pause, try the next one, and when you're ready, come back and see the answer. All right, you should have gotten x equals 2 and AB equals 10. All right, so one of the last things we'll talk about, but it has quite a few applications. Uh, if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. And if you recall, bisect means cuts exactly in half. So if AB, which is a diameter, is perpendicular to chord XY, that automatically means these two pieces of the chord are congruent and these two pieces of arc are congruent. Also, if I see that a chord has been bisected at a right angle, I now know that that line is a radius or diameter. So knowing it's a radius or diameter allows me to say it's the perpendicular bisector. Seeing it's the perpendicular bisector allows me to say it's the radius or diameter. So in example 4, we see that radius SQ is perpendicular to chord PR. So that means it bisects chord PR and arc PR. They tell me that arc, the measure of arc PR, the entire thing here is 98 degrees. And we also know segment TR is 6. We want to find the measure of arc PQ and the length of chord PR. So for PQ, since this is the same as this, so they're equal, which means I can divide 98 by 2, and I would see that the measure of arc PQ is 49 degrees. All right, now for PR. So since these are the same, and this part was 6, I know this part is also 6. So PR is really 6 plus 6, or 12. All right, you're going to go ahead and try the next one. Pause. When you're ready, come back. So you should have gotten measure of arc DE is 75 degrees. And HF is 5. All right, be careful with that HF. They were only asking for the little part this time. They were only asking from here to here, which was the same as DH. They were not asking for the whole thing. That's why it's not 10. The last problem type that we're going to do is the trickiest because it does require us to add some stuff to the picture that wasn't there. So for example 5, in the stained glass window, diameter GH is 30 inches long and chord KM is 22 inches long. We want to find JL. And if you notice, JL is just this little piece right here. It's sometimes easier to redraw the picture without all the extra stuff, right? We have the stained glass here. It's a little confusing. So I'm going to go ahead and look at it without that. All right, I'm going to add the little right angle symbol that was there. So diameter GH is 30. We're going to keep that in mind because that also means then if the diameter is 30, the radius is only 15. We do see that diameter is perpendicular to the chord, making these two congruent, and they're telling us the entire KM is 22. So if they're the same, each one is 11. We are really looking for JL. So what I'm going to do is, because I do know the radius, JH is 15, that's not really going to help me because I don't know how much JL is of JH. But I do know every single radius in this picture would be 15. So what I can do is I can draw another radius. I know anything from the center to a point on the circle is a radius. So I'm going to go ahead and draw JK is 15. Right? I know it's a radius. I know the radius is 15. And now I've created a right triangle. So I'm really looking at a right triangle with a hypotenuse of 15. One side is x and the other is 11. If you remember, anytime we have a right triangle and we have two sides, to find the third, we could use Pythagorean theorem. So that's what I'm going to do. 15 is my hypotenuse, so that's my C. So we're going to get 15 squared equals x squared plus 11 squared. We're going to do our math, right? 225 equals x squared plus 121. Subtract the 121. Now we're going to take the square root. So JL would equal the square root of 104, which is 2 root 26 if you reduced it, or if you gave the decimal, 10.2, and the units in this problem were inches, right? 22 inches, so 10.2 inches, and that would be our answer for this problem. So you're going to go ahead and try the next one. It's the same idea. Notice that UR is a radius, and we do know the two pieces that make up UR. So we know the entire radius length is 11. And if you draw another radius somewhere on here, you should be able to find one of these sections, and we're looking for the entire length overall. So go ahead and pause, and when you're ready, come back and check your work. All right, so we should have gotten TV, that entire length is 18.44. We would have had 9.22 as our x value after doing the Pythagorean theorem. The Pythagorean theorem would have been 11 squared equals x squared plus 6 squared. We get the square root of 85, which is 9.22, and then double it because each of these sections is 9.22. All right, that's it for this section.